Okay, so in this example, the first player is running towards the end zone at 4.1 meters per second, has a mass of 95 kilograms, and he's hit from behind by an 85 kilogram cornerback moving at 5.5 meters per second. So they're both moving in the same direction prior to the collision. And then it says what's their mutual speed after the hit. So you can imagine that the cornerback wraps his arms around the halfback and takes him to the ground. So this would be an example of a totally inelastic collision. So what we're going to do is, we know that momentum is conserved in this type of collision, just like any collision. But in this scenario, we have, before the collision, two separate objects in motion, two separate people in motion. So each of them has their own momentum. So the momentum of the first player would be his mass times his velocity, and the momentum of the other player would be same idea. So we have two separate terms for the momentum before the collision. However, after the collision, they stick together, so they're moving at one mutual velocity, and it's like one mutual combined mass. So over here where I have all of the data, I'm going to write down the thing that I want to know is what I'll call V prime. I'm not going to call it V1 prime or V2 prime, I'm going to call it just V, because they both move at that same velocity, and I use the prime because it's after the collision. So I can write it this way. I'm going to combine their masses into one mass moving at one mutual speed. So this is the combined momentum of the two of them after the collision, and I want to know that velocity after the collision. So I'm going to divide by the combined mass. So I get m1v1 plus m2v2 divided by the combined mass equals v prime, and then I can plug my numbers in. So I have 95 kilograms times 4.1 meters per second plus 85 kilograms times 5.5 meters per second. Notice I called them both positive velocities. They're both moving in the same direction. And then divide by the total mass is 95 kilograms plus 85 kilograms, so that'd be 180. So we plug that in the calculator, and I get that V prime is 4.8 meters per second. We have two sig figs here.